Hi, good morning, and welcome to the FoodSense Gen 4 weekly webinar. So we like to do this weekly webinar once a week, and I'll just jump straight into it. So this week we're actually going to talk about the HPLC testing of chilies and chili powders. I'm going to specifically touch upon the AOAC 99.5.03, the ASTA 21.3, and the FSSAI 24.0. These are different method files that use a technology called HPLC, high pressure liquid chromatography, and these are really methods that run upon that kit. But let me go a little bit quicker and sort of dive into it a little bit. So at ZP, especially under FoodSense, we do a lot of what we call digitization, traceability in the supply chain. That means that we measure things immediately, we get an immediate result. All the results are essentially electronically saved, and so there's a kind of there's a traceability, and there's also sort of custodianship that when you need to sort of prove that something was of a certain hotness, you can always call upon the raw data, not just the number of a certificate, but the raw data as well to prove that. And we use the FoodSense Generation 4 to do this. That'll come later on, but I want to jump into the heart of what we're talking about today. If I go quickly today and you want to have a sort of bit of a refresher on this, we are having a live streaming webinar on the 25th of January 2024. This could be really interesting. Any links that jump up now, I'll try and put those links underneath the video as well. So I want to dive into the problem of things. And the problem of things is if you want to objectively measure the hotness of something like a chili powder, a chili sauce, a chili pepper, a ground up chili, then you've got HPLC, you've got panel testing, which really nobody's doing because it's really too expensive, and you've got FoodSense Generation 4. In the first half now, I'm just going to focus in on the HPLC, and I'll come back to the FoodSense Gen 4 in a bit. One thing to say is when you look at the FoodSense Gen 4, when you look at HPLC, high pressure liquid chromatography, one of the first things I notice is that there are people using what's called the AOAC 99.5.03 method on the HPLC to measure chili powder, and you'll notice in a bit that it's actually not validated for the measurement of chili powder, but I'll get to that quickly. So a couple of, I would say, I want to say big problems, but I don't want to overplay it, but problems with HPLC are cost of test. Now the cost of test, you'll see in a minute, comes from really the complexity of this instrument. This instrument will easily cost you $50,000, 50,000 euros to own. Its running costs are higher than that. It has organic solvents. It has scientific parts that precision engineered. These are expensive to make. They're made in low volume. So a lot about this machine is very costly, including things like it runs organic solvents. So when they're doing the testing of capsaicin, that's obviously the molecule that gives you the sensation of hotness in chilies, when they are running those kind of molecules, they're using organic solvents like acetonitrile. Acetonitrile is a known toxin, let's say, and so they run it and then they have to dispose of it. So it's an expensive cost to buy these solvents and an expensive cost to dispose of these solvents. Another problem then is the method of tests themselves. So I'll bring up that in a little bit. And the biggest one, and I'll sort of show you the documents on this, is that some of the methods of testing are not actually validated for the sample types that people are otherwise testing with. So chili powder being the absolute example there. Just to sort of say, I said I would sort of cover the HPLC part a bit. For scale, you can see me next to an HPLC system that we have. So at ZP, when I'm sort of talking about HPLC, it's not in a sort of a abstract manner. We do actually own this kind of kit. I mean, I'm a chemist. I started using HPLC in 1997. So it's a kit. It's used a lot in the analytical, let's say, industries, but as I say, for all the reasons earlier on, it's actually quite expensive to own. When you look at the hardware, what you find out then is you've got these solvents. These solvents could be like acetonitrile. These solvents are actually sort of pumped. These pumps are not, they're not fish tank pumps. They're very high-end pressure pumps because the whole system is under quite a lot of pressure. There's a sample preparation, but when that sample is prepared, then it's actually injected into the device. So the device is really flowing a stream of organic solvent, and into that stream then you inject the sample. Well, now what the HPLC is doing is it's doing a process called chromatography, which is really a form of separation. So if you were in school and you took a black pen and you put a little dot of black ink on a piece of paper and then dropped a bit of water, and then the water spread out and all the inks separated out, that's an example of simple separation. So in that experiment you could see that kind of the use of filter paper and a little drop, you were able to separate out the dye molecules. Well, in the case of HPLC, they are also doing separation as well. So organic molecules are traveling down this column, things like capsaicin. They're sticking to the column, then they're being released. They're sticking, they're being released. They're sticking, they're being released. And that kind of exchange is quite all molecule dependent. And that means that different molecules, they call it elution, but come out at different times of the column. Then they have a detector. Often they're using a UV vis detector, ultraviolet visible detector. And then they have, when they say data recording system here, I mean, this is really a computer these days as well. So I bring all that up because HPLC, I'm saying that to test things like chili powder and the capsaicin in that chili powder, one of the ways of doing it is the HPLC. Well, the problem you find then is it's costly to do, and it's costly to do in part because of the capex, the capital equipment costs of buying this, and then there's also the operational costs of actually running this kind of equipment. And it's not, the kind of people required to do this are not super low cost type of people. So if we go forward a little bit, now there's methods then that people are using to measure things like chilies and chili powders. There's the Aster method 21.3. Now I've read this online and I'm still looking for more sources of information on this. So if anyone's got any extra sources, I'd be interested. But they've got the Aster method 21.3, which I read, and I need to still confirm this, that they collaborated with the AOAC. So Aster is a trade body in the US for sort of spices and spice trade. And AOAC is an international organization really for making analytical methods for things like the ingredients industry. So two different organizations, but they've actually collaborated, I believe. But there is an Aster method 21.3 and there's an AOAC method for measuring capsaicins in samples called 99.5.03. Now, the reason I bring up this third one, which is this FSSAI 24.0, this is a Indian Food Standards Institute, and it's significant because a lot of actual chili and chili powders are either being consumed or produced in India, and so their particular guidance, analytical guidance, is also relevant to this conversation. But the one that I sort of feel the strongest on is the AOAC 99.5.03. The reason being is that this organization is it's really run by analytical chemists in order to make what they think are the best tests possible. The other one, when you look at the FSAI in a minute, you'll see that actually they're just using the AOAC and the Aster method. Aster is a trade organization, which is kind of primary responsibility is actually trade. Let me go forward a little bit more and just talk about the AOAC for a second. So I do have an AOAC copy here, so I've sort of, I have read it. I do have a copy of it. First thing I notice is this is not applicable to chili powders or products containing oregano or thyme. I don't mind so much the oregano and thyme part, but the part that I want to emphasize here is it's not applicable to chili powders. The reason being is at ZP, we make a low cost, easy to use, fast, I call it, let's say, Scoville meter for measuring things like chili powders and measuring the hotness. And the thing that we notice a lot is that people are doing a lot of HPLC testing. And then what you discover is that the methods that they're using, so it's cost them a lot of money to do on the HPLC. It's not fast. They can't do a lot of testing because of the expense. And then you actually realize that, you're actually using this methodology that is actually not valid for doing this work. So be careful. So HPLC, is kind of entrenched in some degree, but be careful because it's actually, especially the AOAC, is not validated for measuring chili powders, which I know a lot of people around the world, in particular in India, I'm coming across this quite a bit as well. So if we dig into India as a particular example, but it's important to the whole sort of supply chain, I would say, in the spices industry, because India is such a big producer. You've got the the Food Safety and Standards Authority of India, this FSSAI, and they have a manual of methods of analysis of food. So let's just dig into this a little bit deeper and say that if you see a link jump up, by the way, I'll make sure I'll put the link underneath the video as well, so you can kind of go and find, let's say, the primary information here. But if I go into this a little bit, so it says here, which is really interesting, the methods for capsaicin content in chili powder. The next thing that I notice is that they are actually using the AOAC 1995.03 method. So capsinoids in capsicums and their extractives by liquid chromatography method, and then it's AOAC 1995.03. So in fact, when I said earlier on there were 3 methods, really there's only 2. But what I find really interesting is that this is titled Methods for Capsaicin Content in Chili Powder. But as soon as you read almost the first paragraph, it's not applicable to chili powders or products containing oregano or thyme. So there's actually it's no criticism, but there is a contradiction in the statement, because it's titled for chili powders, but in fact, its first paragraph, it's not. And that's in line with what the AOAC say, because this is really the AOAC method, and it's not validated for measuring chili powders. And I think we see a lot of this, that people are getting HPLC certificates of analysis from third-party test labs in India. And then when we do get the certificates of analysis and we look at the method of analysis, you find out it's AOAC 99.5.03, and it's not valid for the chili powder. So in fact, these results that they're kind of relying on and believe in are done on essentially an invalid method. They think the HPLC is a fine instrument, but it's all dependent on the method that you run upon that instrument, and the method is not valid for the measurement of chili powder. I mean, further than that, I've gone and dug into it, and I can see the mathematics that they're using, and these maths are really only valid for ground pepper and chili pepper, and they're only valid for oleoresins, red pepper oleoresins. So you've got to understand that fundamentally it's not just in the title and in the words, but it's also in the maths that they use, that chili powder is not called out at all in those 2 methods. HPLC is a bit of a black box, and I think this is one of the problems. See that when I say a black box, you can kind of see it in my argument here, that it's such a black box that people sort of do believe in those results, and they pay a lot of money for those results. If you read the certificates of analysis, you'll actually find out then that the methodologies used, things like AOAC 1995.03, are not necessarily valid for their sample. So that's a problem. And then we've got this sort of problem of let's say I've got a chili powder. Now with chili powder, it's and I talk about this much more in our webinar. So there is a webinar on the 25th of January. There will be more webinars every month. So just contact us in order to find out. They'll be able to contact us underneath the video as well. So chili powder is very heterogeneous. You've got to take several samples of that chili powder in order to actually understand the range of Scoville heat units across that sample. But because of the expense, people actually take one sample. So the first source of error in the HPLC analysis of chili powders is actually the sampling itself. Then that goes off for extraction and filtration. I'll give you some, when I say off, it either goes to the lab, but it often goes with a third party. And you'll see some of the details about this in a bit. But we start off with this source of error of the sampling. You then introduce an error because of extraction and filtration. This is just nature that this happens. And there's a dilution step, and then there's actually an injection onto the column or onto the machine. That's probably these days fairly consistent, so I'm not going to over complain about that. What you have coming out of the HPLC, and that's why I call it a black box, is because there's actually a chromatogram. There's a raw signal that comes off this HPLC instrument, and that raw signal is converted into Scoville heat units, SHUs, by using a calibration curve. But the black box nature of this is you never really know when that calibration was actually done. Now, I did have a slide earlier on where I talked about the reservoir, the pump, the injector, the injection valve, the column, and then you've got the kind of the recorder and the detector, I should say, detector, and then the recorder. So there's lots of elements to that instrument. When you've got an instrument like that, it tends to go out of calibration fairly frequently. So in fact, you have to calibrate that machine on quite a routine basis. But when people essentially turn that raw signal into Scoville heat units via the calibration, you don't know when that calibration was last done on the instrument. So be super careful about just taking the value that you get on the HPLC certificate of analysis at face value. So it's expensive, there's no transparency to you, and it has more errors in it than we actually realize. If I have 5 manual processes and each manual process has something like a 5% error associated with it, I can build up something like a 25% uncertainty in my final result, which is fine as long as you report it. But what you're going to find out is that this is not reported, so we'll go further a bit. So at AOAC, it's not, the samples that it can take are crushed red peppers, chili peppers, cayenne peppers, jalapenos, aloe resins, but it can't take chili powders. So having said we've got a problem with sampling, extraction, dilution, injection, raw signal, calibration, overarching of all of this is then that the method itself is not actually valid, in particular for chili powders, which people are really kind of keen upon. When you read the methodologies, I find it really kind of interesting actually, because we're talking about extraction here. So it's important, if you want an accurate measurement of Scoville heat unit, then it's important that you accurately weigh out the sample. So it says accurately weigh out, and then it says CA 25 grams. This I find really, it's a real sort of strangeness, because accurate means accurate, do it precisely, or do it accurately. I know the difference between accuracy and precision, that's why I was being a bit careful there, but accurately weigh it out. But by the way, CA means approximately 25 grams. So what is it? Are we accurately weighing it out, or are we just doing it approximately? So there's almost like a sort of a built-in error, because in this one short statement, which is the start of the extraction, it actually means two things. It means accurately do it and approximately do it. So I think they're there, so you're not in that lab to see that process take place. So you don't have a transparency on how well that measurement was done. But any kind of error on that, let's say you made a 10% error on the weighing here, that will translate itself into the final result that you get as well. And for the aloe resin, it's kind of interesting actually, because what I notice is that accurately weigh out 1 to 2 grams. I mean, what is it, 1 or 2 grams? I mean, that's quite one hell of a scale, actually. And then it's very interesting to see, because what I find interesting is the way that it's quite a manual process. They end up with this oil on some glass, and they have to kind of wash it with solvent to get it all dissolved. So that's where some of the cost comes from. That actually there's the person very involved in that sample, really, really doing some, it's not hard work, but it takes a little bit of skill. And then I can therefore see that, this is actually quite a manual process. So there's a sort of, by reading these documents, you kind of realize that actually, people hold the results of this kind of process in super high regard. But if you read the details, actually, you find out that there's some discrepancies, let's say, in accurately weigh 1 to 2 grams. Well, 1 to 2 grams is quite a range, or accurately weigh approximately 25 grams. There's quite a range actually there. That's why I like the FoodSense, because you're the one who runs that test, or your technicians run that test. And so you have a real transparency on the process that actually takes place. One of the things that this is definitely the case, that if you take a sample of chili powder and send it to a lab, you'll get a result. If you send the same sample to a different lab, chili powder again to a different lab, you'll get a different result. And if you send the same chili powder to a third lab, you'll get a different result. So people are paying quite a lot of money for these results, and I can see why, because the equipment's expensive, it's expensive to run, the procedure is actually quite manual, and so when you combine those things with these sort of different labs doing quite a manual process, we'll end up with 3 different results. It's just statistically it's going to happen. But also, if you send the same sample to the same lab 1 month and send the same sample to the same lab at a second month but with a different name, and that means that person's blinded to what you're doing, and they send the same sample to the same lab on a third month with a different name, you'll end up with 3 different results. And again, it's because with such a manual process, they can't help but get three different results. It's just going to happen. So if we were then, and I only use this for educational purposes, if we were to analyze some of these certificates that come back, then you end up with a sample. That's great. You end up with the results. They're using the AOAC method, which in this case is fine because this is chili peppers, but not chili powders, which the method is not valid for. What's interesting is they get the result 11,636 Scoville heat units, but there's no uncertainty indicated. For every measurement, there's always an uncertainty indicated. Is this plus or minus 25%? Plus or minus 25% would be approximately plus or minus 2,500 Scoville heat units. I'm just using approximations here. So it could be quite a bit. So there is definitely a range associated with that result, but you have no sense of it as people take those as absolute results. And then what's interesting as well is that you don't end up with the raw data and you don't end up with a calibration routine. So you're really you don't have much of a sense of it. It's a belief, that result is accurate and you use it accordingly. Don't forget that because of the cost, if you had a sack or a pallet worth of dried chilies, you only send one sample to the lab because it's too expensive to run 5. But it's probably more appropriate to actually send 5 samples to the lab, end up doing the average of the results, and then also do what's called relative standard deviation on the results. So you end up with an average result plus the range that you can expect in that sack or pallet of dried chilies. But nobody does it because it's too expensive for all the reasons I've mentioned earlier on. This is just a kind of use for an example of a certificate of analysis coming from HPLC. And it says here the method or equipment used HPLC. That's really interesting because it tells us nothing really. It just tells us that they use HPLC. But whether this is a valid method or not, you really can't tell just by the statement HPLC. So just something to look out for as well. So the problems that we see is that we have HPLC testing, and there's also a solution that we see, which is FoodSense. But if we look at HPLC testing, whether you're using ASTA 21.3, AOAC 99.5.03, or that Indian method, which was, I think, method 24, the HPLC is intrinsically expensive to own, expensive to run. It leads to what's called under-testing. So if it's a chili powder or crushed chilies, you send one sample, get one result. You really need to be sending, several samples from the bulk sample in order to really understand what's going on with that sample. But it's because of the intrinsic costs, you can't do it. The results can be slow. That slowness comes in part because actually when you read these extraction protocols, they have 5 hours. But it's because you're also taking the sample, packaging the sample, sending the sample to the lab's opening the package, eventually running the test, eventually injecting it onto the HPLC column, eventually going through their calibration routines to turn the chromatogram into a result, and eventually the result comes back to you. So there's a lot of handling there, and so the result is intrinsically slow. And it's a black box with no sense of error. And black box means there's no transparency here. Sample goes off. As soon as the sample leaves your hands and the result comes back, you really have very little oversight to what's going on in those, let's say, processes or those steps. Now with FoodSense, it's much lower cost. It means you can do lots of testing. The cost per test is much lower. You get fast results, and you can. It's a transparent process, and I'll discuss that transparency in a minute. But it comes down to this: the raw data that gives you the number of Scoville heat units is actually something that you can interrogate and view online. But I will delve into that a little bit in a minute. So this is the FoodSense Generation 4. Generation 4 really is a demonstration of how long this has been going on for. We've been doing this for at least 5 years. I'm a little bit wondering when we actually did start this. It was definitely pre-COVID, and it was definitely pre-COVID, sort of a few years even before COVID was ever a thing. So it's smaller these days. This is a handheld size unit. You'll see some things in a minute. It's easy to use. It's not like the HPLC system, which you really need a sort of, a trained technician, analytical chemist, master's chemist, maybe a PhD, to overview all of this. It's more accurate these days, the FoodSense G4, and we can check that accuracy as well. It's cloud enabled, so this is really important because I started this by saying that as ZP were very interested in sort of digitization and maybe traceability in the ingredients industry. So the fact is, every time you do a test, all the results end up on the cloud under your username and password, so you can go back there and interrogate the data later on. It also allows multi-analytes. I suppose that's something I haven't touched upon with HPLC, that we can do chilies, ginger, and something called TAS, total antioxidative status, which is a measurement of your ability to resist oxidation, which is also an indicator of shelf life. I'll start playing these videos, but they're all really referring to the FoodSense Generation 4. So the first one then, I've been saying that this instrument is small, so in the top left hand corner there, that is the instrument. These are the sensors themselves. In this video here, they're showing you there's actually a and if you've got an Android app, it's probably worth getting out in a minute, Android phone, because you can scan a QR code in a minute. But here they're running a chili demonstration, and they'll get a result on their smart device. So when the engineer has run the test, she gets a result on her smartphone. But she's also demonstrating that actually the raw data goes to the cloud, and that's your raw data, and you can access it. And I'll also talk about how you can share it with people like us to actually confirm, that everything's working really well. It's a small matter, but the data we get is very iconic of capsaicin, so we really know it's capsaicin. In the bottom sort of left-hand corner, I'm showing this QR code scanning. So if you want to go from different assays, chili, ginger, TAS, and if there's assays that we're not running, please let us know so that we can add them to the menu as well. So this is a app that you can scan on the Play Store. This will, or the QR code I should say, and this will install an app. And then these are the different tests you can run. So when you open the app, it will ask you, do you want to do chili? Do you want to do ginger? Do you want to do total antioxidative status? So you can just go from different to different analytes, let's say, or different tests by scanning these QR codes once you've got the first app installed. This is the workflow of the device. So we have chili sensors, for example. We have ginger sensors. We also have TAS sensors, total antioxidative status sensors. We have hardware. We have the app, and we have a cloud system for actually storing the data in the cloud. I'll just hide myself for a second just so you can see the instrument. There's the instrument itself. Now what happens is the sensor goes into the meter, the sample goes onto the sensor. So this is partly that transparency part, because in fact you can witness or do the entire test yourself. The meter then tells the app then tells the meter what to do. The meter gives the data back to the app, and the app gives the data to the cloud system called Julie, and you get a result. But for the transparency, and that gives you speed and certainty. So what I mean by speed and certainty is you did most of that, so you can understand if you made any errors. It's not a black box to you. And also, you get a certain amount of speed because you actually did it. So you have certainty that because you did it, and speed because you also were able to do it quite quickly. And in fact, if you come to one of our webinars, for example, on the 25th of January, we do a live streaming webinar there, and you will be able to witness how quickly this really is. Now, the nice thing is you actually get the raw data as well. So if there's any concern about the accuracy, which I made a statement about accuracy earlier on, we can see the raw signal. And I get this quite a lot actually, because we literally, if somebody's got a mild chili powder, the signals are small. If it's medium, the signals are bigger. If it's hot, they're bigger again. There's no doubting the data. Whereas when you've got a certificate of analysis, you've really little evidence of actually that. It's just belief or trust, I should say. And so you get a certain transparency, and you also get a nice support as well, because at ZP we do like looking at data. We do understand the data, and we are able to explain the data to others as well. So that's, every week we do a weekly demo webinar, I should say. This is one of those kind of weekly webinars. I'm helping to support people. So we also provide support, which is only available because in fact the raw data goes to the cloud, and then you can choose to share the data with us in the cloud. So there is a webinar on the 25th of January 2024. I'll make sure I put a link to that. If you're watching this much later on, just know that there's always a webinar every month, so just reach out to us and find out when the next webinar is. I want to wrap up with a sort of thank you. There's a contact us here. So in summary, if I was to say is, there's two real ways of objectively measuring capsaicin or the hotness of the SHUs, the Scoville heat units of chilies. You can use HPLC or you can use the FoodSense. The one thing about HPLC is I would say that a lot of testing is going on those HPLCs. There's a problem with the cost of the testing. So I think there's a lot of under testing going. And there's also a confusion that actually some samples can't be run on HPLC. The methodology is not validated for it, but yet it's going on. And so be careful, because you can't have a accurate result if the method file or the methodology for the HPLC is not validated for that sample type. So that does go on. But of course, we think we solved it all with the FoodSense, but I would rather that you came and see for yourself. So if you are watching this before the 25th of January 2024, then you can sign up for a free webinar. And if you're watching this post January 25th, 2024, don't worry, we do one every month, and just reach out to us and we'll give you the link to the next webinar. Otherwise, have a good day and take care. Okay, thanks very much.